Okay, so hi, let us start with the demo of ADSP. So ADSP is the Autonomous Data Scientist Platform. We will start by first taking an Excel sheet which we would be going to upload in ADSP. So right now I have taken this sheet which represents the Gen Z social media usage. It has multiple columns like age, gender, country, daily usage hours, and so on. And now, as a stakeholder, I know that I would be able to extract relevant insights from this dataset. Now, this is exactly the thing in which ADSP comes. So, we pick this dataset, we browse the files, and we pick the correct dataset. We open it. So now it will upload. Here it uploads. Now I click show me what's in the dataset, and it starts working. Okay, so this shows me what is inside the dataset. So we have the data story where we get the column composition, the number of numeric columns, the number of categorical columns, the missing values if there are any in the column, the numerical distributions of the columns, which includes their mean, their standard deviation, their minimum, maximum. Okay, so now I go on and click the next tab, that is which output variable should I predict. Okay, so this tab essentially measures the predictive signal that is present for the various output variables. So for example, in the current dataset, it is saying that addiction level has a predictive signal of 0.89. Okay, so it has a predictive signal of 0.89. The difficulty would be easy. However, the risk would be high. Okay, so if I click on this card, say, I'll get to know the predictive signal is 0.891. Why is the predictive signal 0.891? What is the formula used to compute it? Okay, so this gives us information about the various columns that are present in the dataset. Okay, be it daily usage hours, okay, be it primary platform. So clearly the inference that I can draw from here is that predicting country, average session minutes of a user, the night usage of a user are difficult from this dataset, whereas predicting addiction level, mental health score is a relatively easy task. Okay, so now let's go to the next tabs that are present. Okay, so let's take addiction level. Okay, let's say what problems exist in the data. Okay, so it reported that there were outliers which were clipped in 4 columns. So we got to know that outliers are present in these 4 columns in the dataset, which is a risky factor in the dataset. Other than that, it reports that there is a class imbalance ratio of 3.74 in the dataset. Okay, now let's continue. Other than that, we have the various charts to visualize the dataset for the user. Okay, so if I click why do the models predict this, this would essentially train certain fixed models that we have on the dataset. Okay, and give us back the results. Meanwhile this is working, we could go and explore the canvas. So this is the canvas. So let me explain the various features of canvas to you. Okay, so we have an agent which has the whole access to the current dataset. Okay, and now the agent can work on the dataset and give us insights about the dataset. Okay, so first of all, we have a know your dataset feature here, which tells us about the rows in the dataset, the current target column, which is addiction level. It tells us that it is a classification task. Okay, the distinct values, the missing values. Okay, now comes the interesting part. The agent itself tells us that what can we investigate next in the dataset. Okay, so for example, it asks me that we can compare night usage and mental health score. Maybe night usage might be related to the mental health score in the dataset. So if I click on run this, the agent starts running with this question. Okay, So it starts executing certain tests. So see, it tests the correlation between the night usage and the mental health score. Okay, it gets a very strong p-value. Now it tries plotting a scatter plot between night usage and mental health score. Since night usage is a categorical variable, so there would be two values in the scatter plot, 0 and 1. So here you go. These are the two values, 0 and 1. So all the data points in the scatter plot would be visible. Okay, so the analysis has finished, and let's see what is the result. So the result is that the night usage has no significant correlation with mental health score. Okay, and this is also pretty clear with the graph as well, that the points are more or less equally distributed between 0 and 1, which implies that night usage does not affect the mental health score. Let's try something else. Okay, so treat daily usage hours, mental health score, night usage as a feature group, and see how they work together. Yes, so let's try this. So again, the agent would start working on this. Okay, so it will again conduct some tests. So for each test, the tests that the agent conducted, the filter it applied, the columns that it chose, the slice description that it chose, and the output, everything is very clearly represented. Okay, so let's say that the agent commits an error, so the agent would retry again. Okay, so meanwhile this is working, the models tab has filled up. Okay, so we see that for addiction level, the software tried applying random forest, gradient boost, XGBoost, logistic regression, expertise, naive bias. These are the standard machine learning algorithms that exist. The software itself applied all of them on the data set and showed us the various metrics like the accuracy, the precision, recall, F1 score, ROC, AUC. Okay, now on the basis of these values, it gives a compositional value, a representative value in the form of trust. And obviously the models having higher trust scores would be preferred and would be given to us as the ones which would be better fits on the dataset. Okay, we also get multiple diagrams here to understand the analysis done by the software. So we have a class distribution here that for addiction level we have the median values to be 59.6%. The low values are relatively lesser and the high values are even more less. Now when we applied the model of random forest, what is the confusion matrix that is given here? Okay, so this essentially tells us that if the actual output is medium, for how many of those data points did the model predict high, the model predict low, and the model predict medium? Okay, so it also gives us the ROC curve, the precision recall curve. Okay, it also tells us the feature importance. So according to the best model that was picked by the software, which are the features which are important for the prediction of the output variable. So here we see that daily usage hours is an important variable for predicting addiction level, and this should be the case because the more a person has daily usage hours, the more likely it is that the person might be addicted to social media usage. Okay, so meanwhile canvas has finished. Okay, let's see what was the output. So it tells us that analysis of daily usage hours, mental health score, and night usage on addiction level. The analysis of the feature group revealed that both subsets, night usage equal to 1 and night usage equal to 0, had a prediction signal of 0. So this implies they are not related. Okay, now we were inferences that we have observed from the dataset. So for example, daily usage hours and mental health score do not significantly predict addiction level. Okay, this is what we understood. Night usage has no significant correlation with mental health. Okay, and so on. We also have a model lab where essentially we could vary these different parameters and check how the results vary. And similarly, we have a prep lab where we can again vary the parameters and understand how the output varies. Okay, so let me come back to the data story tab. So in the data story tab, we also get the multiple visualizations of the data set. So we have the correlations that are present between the various columns of the data set. Okay, we can expand and view this. We have the correlations after feature engineering. Okay, and we have the individual distributions of the various features. Okay, so this is the product.